So guys, today we're going to be talking about a calculus topic. We're going to be talking about what is a limit. So for the basics, a limit is when we have some function and we want to figure out what its value approaches at a certain point. So often the reason we're going to take a limit is because it's undefined at some point and we want to figure out what that value would be. So we take the limit from the left, which is the value that this function approaches as it reaches a from the left, and the value that this function approaches as it approaches a from the right, and we can use that to evaluate the limit. So here's a little bit more formal of a definition of a limit. So if the limit as x goes to a plus of f of x as equals the limit of x as x goes to a minus, then the limit of x goes to a of f of x exists. So what this means is, again, if we have our a value and we look just a tiny bit to the right and just a tiny bit to the left, in theory these should be infinitesimal values, then if these values are equal, then that's also the value of the limit. If these values aren't equal, which means probably that we have a jump discontinuity in our graph, so it goes from here up to here on the right side, then our limit does not exist. Okay, so now let's look at some examples of evaluating limits from graphs. So here we have this function, and as you can see at 0 it's actually undefined, so we have a hole in our graph. So we're going to start by naming f of 0. As you can see, it's undefined, but we actually do not care that it's undefined because we are taking the limit, and the limit is actually unrelated to the function's value. So this is what's called the limit from the right, so we're going to imagine we have a point 0 plus right here, which is just barely to the right of 0. So what's the value at that point? The value here is 1, so that's our right limit, and from the left we're going to imagine we have just to the left a point here, and this is also 1. So that's the limit from the left. And as we saw in the previous slide, since the limit from the right is 1, the limit from the left is 1. Since those two limits are the same, that's going to be the value of our limit at 0. Okay, here's another problem. We have a reciprocal function with a vertical asymptote here. So f of 1 is going to be undefined because we're going to have a number over 0 situation. So it's going to be undefined. And if we look at the limit from the right, as you can see, these y values are shooting up to infinity. And these y values at the left, as you can see, they're going to go down to infinity, negative infinity. And so in this case, the limit from the right does not equal the limit at the left. So this is actually not going to have an answer. So we're going to call this DNE, which is does not exist. So this limit does not exist at this point. Okay, we have another situation here with a reciprocal function. So f of 3, depending on who you talk to, since this is a vertical asymptote, this can either be undefined or infinity, but I'm just going to go with undefined right now, since we're going to have some number over 0 in this situation. That's why we're going up to infinity, so I'm going to call that undefined. And if we look at the right side here, y values are shooting up to infinity, so the limit from the right as x goes to 3 plus is infinity. If we look just to the left of x equals 3, we also have y values shooting up to infinity, so that's also infinity. And so finally, since our limit from the right and our limit from the left are exactly equal, that's also going to be our limit at x equals 3. Okay, one last example here, we have a piecewise defined function. And here actually we do have an f of 2 that is defined. So f of 2 here is going to be 3. As you can see, we have this solid point here. And if we look at the function from the right side, it's approaching y equals 1 right here, even though it's undefined right here at this point, because the point is actually up here. So this is going to be 1. But as you can see from the left side, there's actually no definition for the function between 1/2 and 2, so there's actually no value that it's approaching from the left side. So this is undefined. And so in this case, even though we actually did have a defined value for f of 2, since the limit from the right and the limit from the left are not the same, we actually do not have a limit at x equals 2. Okay, this was a short video. I hope you guys found this helpful, and I'll see you in the next one.